All right, so we are going to start 4.5 is going to talk about integration by substitution, and there are a bunch of steps that go along with this, so I'm actually going to flip the paper over and I'm going to write the steps underneath where it says the homework assignment here, just so that you have it written down somewhere. All right, so number one, you're going to pick your u, which basically is the function inside of the other function. Okay, so you're going to pick your u value. Number two, we're going to find du, which is the derivative of u. Number three, we're going to sub u and du into the integral. Okay, so we're going to sub it into the integral, and we should have no x's should be left over. Number four, we're going to integrate. And number five, we're going to plug back in your u. Plug back in what u equals. Okay, so let's just practice a little bit basic here. So if we look at a, we've got x squared plus 1 squared and 2x. Okay, well the function inside of the other function would be your x squared plus 1. So there's your u. So step two, we take the derivative of that function, which is 2x dx. Okay, now what you should find is when you look at the function itself, we picked this as our u, and then what you see is this is your du. So when you sub it back in, you have u squared du, and you have no x's left over. That is the ultimate goal. That is what you want. So the integral of u squared is u to the third over 3. Now there's no evaluating here, so you need your plus c's back. And then your last step is, because your original function started with x's in it, your final answer needs to. So you're going to just sub back in what your u equaled, which was x squared plus 1. Now it's to the third over 3 plus c. And there's your final answer. Okay? Now let's do right underneath it first for c. So similar idea, we have the x squared plus 1 in the being raised to the second power. Du would then be 2x dx. And so if we look back at the problem, we see, all right, well I have my u, but my du, I don't have this 2 here. So I got to get rid of it. So I got to divide by 2 on both sides. So that means that 1/2 du equals x dx. You don't want extra stuff there. So now when I sub it back in, my u is still to the second power, but my x dx is equal to 1/2 du, not just du itself. So now I'm going to bump this 1/2 out in front. So I have 1/2 the integral of u squared du, which we've already integrated up above, u to the third over 3 plus c. So that gets me u to the third over 6 plus c. And then your last step would be to just sub in your u value at the end. So just don't forget, you have to make sure that your du is completely accounted for and that your u value is accounted for in the problem. All right, let's look at the trig ones now. So the nice part with trig is, not always, but many times when you look at a basic trig problem, you're going to start with what's in the trig function. So your u is going to be, wrong color. So your u is going to be 5x, okay? So then the derivative of 5x is 5 dx, which, if you notice, here's your u, and then these two put together make your du. So when you sub it back in, you end up with cosine of u du. So all you're integrating is just the cosine. In the integral of cosine, you say, okay, what trig function has a derivative of cosine? That's the sine of u plus c, and then you just sub in the 5x back into the problem. Okay, now all trig functions don't necessarily fall into that format, like in D. So the first thing I would do here is to rewrite it. So this is the sine of 3x to the second. times cosine of 3x. So you can't just pick a 3x, because what you're going to run into is you're going to hit a wall, because then you have the cosine of u and the sine of u. So you got to pick a different u value. So what I would do is I would pick u to be the sine of 3x, because that's in the function being squared. So then using chain rule, the derivative of the sine of 3x would be cosine 3x times 3 dx. We don't have a 3 going on here, so this 3's got to go. So 1/3 du equals the cosine of 3x dx. But that we're good with, because here's your du and here's your u. So now when you sub it back in, you have the integral of u squared, and then we have 1/3 du. The 1/3 gets kicked out in front. We're going to integrate u to the third over 3 plus c. And then I can do two things at once. So I can sub back in my u value, now to the third, over 9, and I can simplify, plus c. And there's your final answer for that one. All right, we got 2 more on the back. So if you have a fraction, a lot of times your denominator, or at least the value that's being raised to the second, is going to be your u value. The derivative of that denominator would then be negative 4x dx. So just be careful. We still are combining derivatives inside of integrals here. Now that is my numerator. Okay, so now when I sub it back in, I've got 1 over u squared, because my u is in the denominator, times du, which I'm going to bring up so I don't have to use, I don't have any rules right now for dividing with integrals yet. So u to the negative 2 comes up. When I integrate that, I get u to the negative 1 over negative 1 plus c. I get negative 1 over u when I simplify. And then the final step would just be to plug back in what your u value actually equals. And then again, don't forget, we're not evaluating. It's not a definite integral, so you need to make sure that you have your plus c on these. All right, last problem. So you see a square root. Good idea is to try and see if that's the value that's going to be your u. So u is equal to 2x minus 1. Du would then be 2 dx. But you notice I don't have any 2 here, so I got to get rid of the 2. But this is like type 3 here. What you do notice, though, is you've got this extra x lying around here. So you have to account for that x in the problem. You can't just take it out. So what we have to do is we need to solve for x. And the only place we can solve for x is by taking that first equation. So if we take that first equation and we solve for x, we end up with this term right here. So this is where you're going to have multiple things to sub in. So we have the integral of x, which is u plus 1 over 2, square root of u, but I'm going to write u to the 1/2 instead. And then dx is 1/2 du. So there were 3 things we had to sub in. We had to sub in x, this was u, and then dx was equal to 1/2 du. So x was this fraction right here. So just be careful. So now what I would do is I would take all of the unnecessary terms out. So these guys are not needed. So I'm going to pull out a 1/4. So I have u plus 1, u to the 1/2 du. I'm going to distribute. So I get u to the 3/2 plus u to the 1/2 du. So that's 1/4 u to the 5/2 over 5/2. Remember, the 5 stays on the bottom, 2 comes up. U to the 3/2, 3 stays on the bottom, 2 comes up, plus c. And then I've got 2 things left. I've got to distribute in that 1/4 and simplify. And then I have to plug in my u value. So I get 2, let me do the u first, 2x minus 1 to the 5/2 over 20, plus 2x minus 1 to the 3/2 over 12, plus c. And then my final step would just be to simplify those coefficients. So this should really be over 10, and this should really be over 6. And then your plus c at the end. You don't need to simplify to make it